Welcome back to our channel and back to the tutorial for machine learning. Today we're going to discuss the part 1, that is measure of dispersion in machine learning, or you can say measure of spread also. Let's go for session today. When you like the channel, please subscribe and share with the friends. So here measure of dispersion, we can say it always measure the scatter of data that is now can say some of the far values in the distribution are there's also these measures always capture the variation between different values of the data. So and moreover these are categorized into two things. One is called absolute measure of dispersion, another called relative measure of dispersion here. Moreover these are measured and expressed in the units of what data themselves only. Example, so what kind of relative we can say example for this measure of dispersion, we can say meters, dollars, kilogram, etc. These are the some absolute measure of the dispersion. And moreover, some of the absolute measure of dispersion, we can say range, mean deviation, standard deviation. Today we are going to discuss only the range with some examples. So what is range? Here we can say range, it always defined as the difference between the largest and the smallest value in the distribution. And mean deviation. Mean deviation, we can say it's generally the arithmetic mean of the difference between the values and the mean. And standard deviation, we can say this is square root of the arithmetic average of square of the deviation measured from the mean. So everyone have some formula. We can do it with the help of some example. So range. So just now the range I told you, and we can write. How do you find and write? We can use a formula called R is equal to L minus S, where L stands for what? Largest value in the distribution, and S stands for the smallest value in the distribution. So here, for example, you can say, let's say assume that we have data like 10, 20, 15, 0, 100. The smallest value S in the data is equal to 0, and largest value automatically can say that is 100. So here R is equal to 100 minus a 0, that is 100. And range for ungrouped data. Let's say question number 1, you have ungrouped data. Find the range for the following observation. So let's assume the data like 20, 24, 31, and so on 61. Now solution is what? Same, you can apply the R is equal to just not only S minus L minus S. So you can apply the formula. So the largest is 61 and small is 17. So the range become automatically 61 minus 17, that is 44. Similarly, come for group data. If you go group data, let's assume that there will be a problem given. Find out the range for the following frequency distribution table for the marks scored by class students. Let's assume that you have mark in rows of 0 to 10, 10 to 20. Similarly, 20 to 30 and so on. And the number of students here 0 to 10, 5, and 10 to 28 and so on given here. Let's go for solution. The simple solution is what? The far largest value minus take higher limit of the highest class equal to 40. The smallest value minus take lower limit of the lowest class 0. At last, the range become 40 here as per the what data given in the table. That is table given. Okay. This is about the measure of dispersion part 1. Remaining, we'll see in the upcoming session. Thank you.